All machine learning engineers aspire to attain precise predictions through their algorithms. These learning algorithms can be broadly categorized into supervised and unsupervised. K-means clustering falls into the unsupervised category, wherein the input data lacks labeled responses. So hello everyone, my name is Mayank and welcome to this fantastic video on K-means clustering algorithm. In this video, we will delve into K-means clustering algorithm topics like what is K-means, type of clustering in machine learning, advantages and disadvantages of K-means clustering, and application of K-means algorithm. At the end of this video, we will implement hands-on using the K-means algorithm. So without any further ado, let's get started. So what is a K-means clustering algorithm? So K-means clustering stands out as an unsupervised learning algorithm devoid of labeled data. Unlike its supervised counterparts, its primary function involves partitioning objects into clusters that exhibit similarities within but differ from objects in other clusters. The variable k in the K-means denotes a numerical value, indicating desired number of clusters to be formed. For instance, setting k equals to 2 implies the creation of two distinct clusters. Determining the optimal value for k in a given dataset is a crucial task. So to illustrate the concept of K-means, consider a cricket scenario. Imagine having data on a numerous cricket players worldwide, detailing their runs and wickets in the last 10 matches. The object is to categorize the players into two clusters, batsmen and bowlers, exemplifying the application of K-means in a grouping similar data. So moving forward, let's discuss types of clusters. So clustering is a type of unsupervised learning wherein data points are grouped into different sets based on their degree of similarity. So the various types of clustering are hierarchical clustering, partitioning clustering. So hierarchical clustering is further divided into agglomerative clustering, divisive clustering. So partitioning clustering is further subdivided into K-means clustering and fuzzy C-means clustering. So moving forward, let's discuss some advantages of K-means clustering. So number one is simple and easy to implement. So the K-means algorithm is easy to understand and implement, making it a popular choice of clustering for the task. The second one is fast and efficient. K-means is computationally efficient and can handle large dataset with high dimensionality. The third one is scalability. K-means can handle large dataset with a large number of data points and can be easily scaled to handle even larger datasets. The fourth one is flexibility. K-means can be easily adapted to different applications and can be used with different distance metrics and initialization methods. So now moving forward, let's discuss some disadvantage of K-means. The number one is sensitivity to initial centroids. K-means are sensitive to the initial selection of centroids and can converge to a suboptimal solution. The second one is requires specifying number of clusters. The number of clusters K needs to be specified before running the algorithm, which can be challenging in some applications. The third one is sensitive to outliers. K-means is sensitive to outliers which can have a significant impact on the resulting cluster. Moving forward, let's discuss some application of K-means clustering. K-means clustering is used in a variety of examples of business cases in real life, like academic performance. Based on the scores, students are categorized into grades like A, B or C grade. The second one is diagnostic system. The medical profession uses K-means in creating smarter medical decision support system, especially in the treatment of liver alignment. The third one is search engines. Clustering forms a backbone of search engine. When a search is performed, the search result need to be grouped, and the search engines very often uses clustering to do this. So the number fourth is wireless sensor networks. The clustering algorithm plays the role of finding the cluster heads, which collect all the data in their respective clusters. So now let's move on to the demo part.
So hello guys, welcome to this demo part of K-means clustering algorithm. So this is our Jupyter kernel. So first I will rename it. So we will do some iris flower classification and we will make some clusters, okay, using K-means clustering algorithm. So here I will write K-means cluster iris flower. Okay. Yes. So first we will import some major libraries, right? Okay. First we will import some major libraries like import pandas as pd, then import numpy as np, then import matplotlib dot pyplot as plt. I hope everyone knows, because these are some basic libraries of machine learning, or you can say Python. Okay, this matplotlib is used for the plotting of graphs. Then we will import seaborn as SNS. Then from sklearn dot cluster import k-means. Then from sklearn dot matrix import Silhouse. Okay, score. Then from sklearn dot preprocessing import min-max scale. Okay, so let me run it. Okay, everything is working fine or still loading, right? So these are some major okay, there is one. Okay, there is a spelling mistake. Yeah. So now we will read the dataset. So you can find the dataset link from the description box below. Iris equals to pd dot read underscore csv, then iris dot csv, right? Then x equals to iris dot ilog, then colon comma 0 comma 1 comma 2 comma 3 dot values. Okay, so moving forward, we will see some basic function of Python like info or shape, like describe. So I will write iris dot info. Why iris? Because I gave here my data frame name is iris, right? Okay, and I need iris of 0 to 10 range. Okay, so as you can see, this is my data set. This is IDs, sepal length, that sepal width, petal length, petal width, and species. Okay. So moving forward, we will set the frequency distribution of this particular species. So first, let me give some spaces for better visual. So here I will write iris underscore outcome equals to pd dot cross tab, then index equals to iris and species, comma columns equals to count, right? Here I will write iris underscore outcome. Okay, so here we will make the cross tab, and we are naming the count column. Okay, so as you can see, the species iris setosa is 50, and iris versicolor is 50, and iris virginica is 50. Okay, so these are some count of particular species. Okay, this is species, right? So moving forward, we will set the distribution. So I will write iris setosa equals to iris dot log and species equals to iris setosa, right? Okay, here I will write iris, right? Okay, so we will do this for iris virginicolor and iris versicolor and virginica also, right? So what I will do, I will just copy it and paste it here for 2 times. Then I will change here this versicolor and virginica, right? And here I will change the name versicolor and virginica. Spelling mistake. Right. Okay, cool. Everything seems good. Iris versicolor and iris spelling is right. Virginica. Okay. So moving forward, we will plot some graph, right? And we will see the particular density of the petal length and petal width. Okay. So what I will write here, I will write here this SNS dot facet grid iris comma hue equals to species, okay, comma size equals to 3, comma dot map, then SNS dot distinct plot, comma, I need first petal. Okay, what I can do, I can copy here from petal length and paste it there. Why I'm doing, because of some spelling mistakes. Okay, then dot add underscore length legend, right? So this we will do for the petal width and the sepal length. So what I can do, I can just copy it. Okay, so I can just copy it and paste it here for the 2 times. Then petal width I need change here, and then I need sepal length. Okay, okay, some error is there, right? What it is saying, name of index petal width slash slash t object item call width, some spaces. Yeah, you can ignore these warnings, right? So this is the density of petal length and the particular 3 species, Setosa, versicolor, virginica, because we have only 3 species in particular, data set, right? This is the sepal length of the density. Got it? So moving forward, what we will do, we will make a box plot of the petal length. So I will write SNS dot box plot x equals to species, comma y equals to petal length. Okay. CM, this is the right name, comma data equals to iris, then plt dot show. Okay. Box plot, it is plot. Yeah. So as you can see, the petal length of the particular species, which is iris setosa, is between 1 and 2, then versicolor is is between 3.5 to somewhere 5.3 or 5.2, as you can see, right? So moving forward, we will make different kind of plot, which is known as the Violin plot. VIOLIN, Violin plot. So here I will type SNS dot violin plot, then x equals to species comma y equals to pattern length cm, okay, comma data equals to iris, right? Then plt dot show. Okay, some error is there. Pattern length spelling is wrong. Yeah, so this is some violin plot. As you can see here, the shape are of violin, right? Okay, so moving forward, we will do one major plot. We will make some major plot known as the scatter plot, right? So for that, I will write here sns dot set style white grid, right? Then sns dot pair plot iris comma hue equals to species comma size equals to 3, and plt dot show. You can ignore, always you can ignore these warnings. Okay, see, as you can see here, the particular scatter plot for the sepal length in this, this blue color resembles the setosa, and this orange color is versicolor, and this green color is iris virginica, right? This is for all the full graph, the sepal length, sepal width, petal length, and petal, right? Okay, so moving forward, what we will do, so here k-means. So k-means is a centroid based algorithm or a distance based algorithm where we can calculate the distance to assign a point to a cluster, right? So in k-means, each cluster is associated with a centroid. Okay, so how to implement k-means clustering, right? So first choose the number of clusters k, small clusters, or select the k random points from the data as centroids and assign all the points to the closest cluster of the centroid, right? And then recompute the centroids of newly formed clusters. Then you can repeat the steps 3 and 4. Okay, so here what we will do, first we will find the optimum number of clusters for k-means classification. First we will do that. Okay, so here I will write from sklearn dot cluster import k-means and wcss, just giving as blank array. Okay, for I in range 1 to 11, right? So k-means equals to k-means, then n clusters equals to I comma init equals to k-means, right? Then max iteration would be 300 comma n iteration equals to 10, and random state equals to 0. Got it? Then k-means dot fit x, right? And WCSS dot append k-means dot inertia. Yeah, k-means is not okay. It's small k. Init should be in either k-means is random available for. Got it. What I will do is yes. So now moving forward, using the elbow method. So what is elbow method, right? It's a base graph, okay, elbow shaped graph, you can say. So using the elbow method to determine the optimal number of cluster for the k-means clustering. So we will create here. So we will create here one elbow method graph, right? So for that, I will add plt dot plot range 1 comma 11 comma WCSS and plt dot title the elbow method plt dot x label number of clusters. Then I will write plt dot y label WCSS plt dot show. I think you guys are confused what is WCSS, right? So WCSS means within clusters sum of squares. Okay, so I will run it. So as you can see, this is the elbow shape graph, right? So these are the number of clusters. Okay, this is within cluster sum of squares. This is right 5,000. This. Okay. So moving forward, what we will do, we will implement the k-means clustering right now. Okay. So first I will give some space. Yeah. So I will write k-means equals to k-means n underscore clusters equals to 3 comma init equals to k-means, right? Okay, I can copy it from here. Got it? Then y underscore k-means equals to k-means dot fit and predict x. Okay. So here what we will do, we will visualize the cluster. So I will write plt dot scatter x y underscore k-means equals to 0 comma 0 comma x y underscore k-means equals to 0 comma 1. Then I will give comma s equals to sepalon to 100. Then c equals to, it should be purple, right? And label equals to iris setosa. Okay. So I will copy this for the other Virginica and versicolor. right? And I will change here to orange and green. Then here I will write Virginica. Then here I will write versicolor. Okay. Okay. So what I will do, I will change here. Then 2,1. Okay. And here 1, here 2. Right. Yes. So as we can see, we have scattered particular cluster of between the species, right? The iris setosa is this purple. Okay, this purple one is iris setosa, and this versicolor is the orange. Okay, and the this virginica is the green, right? So how we did? We use this, right? This sepal length, sepal width, and petal length, petal width, and according to that, we just made the cluster of using k-means clustering. So now what we will do, we will plot the centroids of the clusters. Okay, and I will write here only plt dot scatter k-means dot cluster centers comma k-means dot cluster centers, right? Colon 1, colon comma 1, comma s equals to 100 and c equals to red. So what will happen? We will find the centroids. Okay, particular centroid. So I will write here red, then label equals to centroid. Okay, centroids. Let's put then plt dot legend. So as you can see, these are some centroids of the particular graph. Okay, right? So moving forward, we will make our last scatter plot of 3D scatter plot. Okay, for the centroids, to check the centroids. Figure equals to plt dot figure. It's same like above. So what I will do, I will copy it and paste it here. Okay, so now we will do for the centroids. It's same, and I will copy it here. I copy it 2 times. So as you can see, this is our 3D plot for to check or to find the centroids, right? So these red colors are the centroids. Okay, see, I have set the red color, the centroid, particular centroid. Okay, so yes, so this is how you can do or implement the k-means clustering to find the centroids. Okay, so with that said, we have come to end of this video. If you have any query regarding any of the topic in this video, please do let us know in the comment section below. Our team of experts will help you as soon as possible. Do like, share and subscribe. Do like, share and subscribe to stay updated from the Simplilearn channel. Thank you and keep learning with Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.